the grid is a really impressive and performance system, but it's very old and it's not sized for modern power demand. It's really also not sized for where power demand is going. And there are really two ways that we can deal with that. One is to upgrade existing infrastructure, which has its own challenges, whether you consider the lead time for equipment like transformers, which are well publicized to be in a broad shortage, or just the manual issues required with installing poles and wires and getting trucks and crews out to do these upgrades. The alternative is to outfit existing infrastructure with additional capacity in the form of distributed storage and generation, and then using software to optimize those assets to scale the grid's capacity. So the latter is really what we're focused on at Base. We think it's the best way to prepare the grid for all the growth that's coming.
Welcome to Research Radio, the official podcast of Contrary Research. Contrary Research is the best starting place to understand any private tech company. In each episode, we'll dive deep into the most important conversations and companies in technology. I'm your host, Kyle Harrison, General Partner at Contrary. For more info and to read our full reports, you can check out research.contrary.com. Myself, guests, and Contrary may hold financial positions in the companies discussed. This podcast is for informational purposes only and should not be used for investment advice. The electric grid is one of the most complex machines in the world. In the US alone, the grid connects over 12,000 power plants with more than 160,000 miles of high voltage power lines and millions more miles of low voltage distribution lines. At Contrary, we've been fascinated by this topic for years. We wrote an essay in Foundations and Frontiers focused on modernizing the electric grid. The first grid in the United States dates back to 1882, when Pearl Street Station, the first commercial power plant, began generating electricity. Over the last 150 years, the grid operated on a pretty balanced basis. The supply was stable, generated through pretty reliable fossil fuels, and demand was predictable with repetitive daily fluctuations. But now, both the supply and demand for electricity are getting increasingly volatile. The share of renewables, particularly solar and wind, in the energy mix is growing exponentially. But these are intermittent energy sources. The sun or wind can't be switched on or off like a coal power plant. On the other side, the electrification of the economy, and in particular the increasing use of electric vehicles, is making demand higher and more volatile as well. So the grid is facing new pressure, which it just wasn't built for. That's where the Base Power Company comes in. Started by Zach Dell and Justin Lopas in 2023, they're focused on building the modern power company of the electric era. Base is building a distributed battery storage portfolio by becoming a customer's retail electricity provider and providing customers an energy storage system to help ease pressure on the grid by adding storage capacity next to demand load. Base provides its customers with an all-inclusive service with a home battery, monthly energy service, and installation with no requirements of solar installation. The Base battery protects customers from power outages and enables Base to lower average electricity costs. My partner Will Robbins sat down with Zach and Justin to unpack exactly how they're positioning the Base Power Company for the future of the electric grid. Here's this conversation.
Gentlemen, thank you so much for joining here.
Yeah, thanks for coming by.
So you're building a very complex business with many moving parts across software, finance, and obviously hardware and manufacturing. Before we dive into Base itself, I want to start with your motivations. You must have a really strong sense of mission to build a business as complex and challenging as this. Zach, I've heard you use the line, there are no rich, energy-poor countries a few times. What does that mean?
Well, if you look at energy costs and GDP per capita, they're inversely correlated. So very simply, if you can lower the cost and increase the availability of power, you make people's lives better. So you won't find a country that is energy poor and wealthy on a GDP per capita basis. So our mission at the company is to promote human prosperity through energy abundance. And what that actually means is making power more affordable and more reliable for homeowners.
So why focus on the Texas grid specifically?
Well, Texas is the place we're focused initially because it's the place where we believe the problem is most severe. But we think that Texas is a canary in the coal mine for the rest of the country. So Texas is interesting for a number of reasons. First, it's in the middle of the Sun Belt and the middle of the wind corridor. So it's got a lot of wind and a lot of solar. It also happens to be an island grid. So it's kind of on its own, so to speak, in terms of supply and demand. It has a lot of peaky residential HVAC load due to the really hot summers and the sometimes unexpectedly cold winters. So it's a particularly interesting place to deploy battery storage. It's also got a lot of growth. It's one of the fastest growing parts of the country. There's lots of electrification happening in transportation, at the home level through electric heat pumps, at the industrial level with new AI data center loads coming online. So it's really a place where battery storage is heavily incentivized to be deployed quickly. And that's the reason why we decided to start the business here.
So you've talked and written extensively about how transmission, not generation, is now the biggest barrier to decarbonization and one of the weakest elements of our energy system overall. What are the biggest vulnerabilities and drawbacks of the grid today in your eyes?
Well, the grid is a really impressive and performance system, but it's very old and it's not sized for modern power demand. It's really also not sized for where power demand is going. And there are really two ways that we can deal with that. One is to upgrade existing infrastructure, which has its own challenges, whether you consider the lead time for equipment like transformers, which are kind of well publicized to be in a broad shortage, or just the manual issues required with installing poles and wires and getting trucks and crews out to do these upgrades. The alternative is to outfit existing infrastructure with additional capacity in the form of distributed storage and generation, and then using software to optimize those assets to scale the grid's capacity. So the latter is really what we're focused on at Base. And we think it's the best way to prepare the grid for all the growth that's coming.
So let's rewind a little bit to the founding story. Zach, you and I first met at a mutual friend's house when you were a VC at Thrive still. And then, Justin, you were head of manufacturing at Ondrill, another company we know well. How did you two meet, and how did you settle on this of all things to go build?
Yeah, well, we made the angel investment at Thrive, and I went down to do a factory tour, and Justin was my tour guide. And we became friends and hit it off and started talking about big ideas and different technologies that we both found interesting. And I think both recognized that we had complementary skill sets and a shared drive and interest in solving really big, hard problems. And towards the end of 2022, early 2023, we both started getting excited about opportunities in energy with respect to the power grid and battery storage. And we kind of over time started picking up steam around the idea to deploy distributed storage on the grid here in Texas, and then, of course, more broadly across the country over time. And just kind of decided that this was the pitch that we both wanted to swing at. And in the summer of 2023, left our jobs and decided to go for it.
Yeah, it's I think the really exciting and interesting part of the problem for me, and I think for Zach as well, is that it's a technological problem, right? I have an engineering background. That's what gets partially what gets me excited. It's an economic problem, right? Because energy and economics are kind of very, very intertwined, as Zach was mentioning earlier. And it's just a really difficult operational problem, right? Like the grid is by definition basically everywhere that people are. And so you have a lot of physical real world infrastructure that is just super exciting to work on. And there's not, unlike certain other businesses where you might just be solving a technical problem, just be solving an economic problem, starting a investment firm, whatever, solving an operational problem, small business, doing, home installs or something like that. This is all of those. And it kind of works all areas of the brain, which is a lot of fun.
Yeah, I think both of us and the team here are really all people who are attracted to these multidisciplinary problems. I think we categorize the business as kind of one that is solving a complex coordination problem. And you see that when you're here, right? You'll need hardware engineers and software engineers and manufacturing engineers working on operations and folks working on policy and financing and all of the things in between, building a consumer brand, acquiring customers. And I think the team here is made up of people who are excited to solve problems across disciplines. And when Justin and I came together, that was really the opportunity we saw, was to take our very, very different skill sets and bring them together to solve this multidisciplinary problem.
So we've talked about the why of the business. We've talked about a little bit of the origin story. Maybe now's a good time to just explain in detail, like, what is Base Power, right? And what are the different pieces from the retail energy provider element to the actual battery hardware to the software that powers it all? Can you just walk us through how the platform all fits together?
Yeah, really at its core, Base is a distributed energy business that is developing technology to scale existing grid infrastructure. So what that actually means for customers is if you live in Texas, you can sign up for Base and we'll install a battery on your home that'll protect your home from power outages. We also then become your electricity provider, and we're able to save folks on the order of 10 to 20% on their power. So when the grid is up and running, that battery we install in the house is used for grid services. We use that battery to support the grid in times of need. And when the grid goes down, you get that battery to back up your home. So the customer gets all the benefits of home backup without the high upfront cost. And we get to go build out our network of storage assets in a really advantaged way.
Maybe just another helpful point of context for folks not familiar with Texas or don't live in Texas or the Texas grid. In Texas and certain other places in the U.S., a lot of it is in the Northeast. If you're a homeowner or you're buying power, you can choose who you buy your power from. So that's the retail electric provider model. So if you live in California or Michigan or Wyoming or whatever, you can't. The utility, the vertically integrated utility, is the only option for you to buy your power. In Texas, you have an option. So if you live just north of Austin, as an example, where we started our first deployments, you can choose from a bunch of different options for who you buy your power from. That is, we are one of those options, and obviously do the whole battery install and everything that Zach just mentioned. We just wanted to make sure that was kind of clear to folks listening, that that's specific to the way in which we're going to market today is through a retail electric provider model.
And so how do those dots connect to combine that model with batteries, installation, manufacturing, and so on?
Yeah, so the REP stands for Retail Electric Provider. The REP part of our business is really the way we think about it is the way in which we're going to market, right? So if we were to start in Wyoming or any of these sort of regulated states that I was referring to, we would have had to go and interface directly with the utility from a financial perspective, right? So you'd have to, if I put a battery on your home in California or Wyoming, we wouldn't be in sort of the economic transaction that battery provides to the grid. The utility would have to work some sort of deal with us, for lack of a better term. So the REP is the way in which we're going to market to begin with today, and that is how we're monetizing the value of the battery. So we said, okay, we want to put distributed energy storage assets on the grid. How do we go to market? We use the retail electric provider model. We go direct to consumer, so that's kind of the growth part of the business. And then it's like, okay, let's talk about the hardware and the software. We could maybe go buy some hardware and use somebody else's software, but there's not really anything on the market that is set up for that business model that I just outlined. There's not hardware that has a large enough discharge capacity. It's not easy enough to install. It's not meant for this business model. And so we said, okay, we want to develop the hardware and the supporting software to support that go-to-market motion that I mentioned earlier.
Yeah, at its core, BASE is a distributed energy technology company. The asset, the kind of core asset of the business today is battery storage. Eventually, that might look like battery storage and solar generation and other assets, but really the value in the business is in building out our fleet of storage. We believe we can deploy the largest and the most capital-efficient portfolio of battery storage in the country. That is enabled by the technology that we're developing. The technology is battery hardware that is designed for the use cases Justin was mentioning. It is software to enable that battery hardware to perform that use case. And then it's the deployment operations, what we call the deployment factory, to get that asset in the ground very efficiently at scale. The retail electric provider is, to Justin's point, how we bring that technology to market and how we build out that asset base over time. In the regulated markets, we may use a different business model, not leveraging a retail electric provider, but working directly with investor-owned utilities, municipal utilities, co-ops, to deploy the same asset, battery storage, just behind a different business model, which is kind of more a function of the market structure and less about kind of the core thing that we're doing here, which is developing distributed energy technology.
So there's a lot of trends underlying the timing as to why now is the time to go build BASE. In no particular order, there's the changes in demand for energy. There's the change in cost for like solar and other renewable forms. There's obviously the change in battery cost has been a huge trend that's underpinned companies like Tesla and their ability to succeed. How do you think about the timing overall of BASE and kind of what inputs and what cost curves went into the business being possible in the first place?
You nailed it, right? There's kind of two main ones I think that we could highlight here. The first one is demand for electricity specifically. So if you look over the last few decades, electricity demand growth has been not super high, honestly. It's been like a few percent kind of per year, compound annual. And now a lot of the end use of energy is moving from fossil fuels. So this is like gas in your car or natural gas for your stove to electricity. This is EVs and induction stoves as an example. And so just with the shift away from fossil fuels into electricity as the end form of energy has a large increase in electricity demand. Additionally, all of the new loads that Zach is mentioning in electrification of heavy industry, AI, and data centers, that is increasing the demand for energy, and all of that energy is being consumed in the form of electricity. So demand growth is certainly one of those trends. The other is declining cost curves and increased sort of maturity of technology surrounding the fundamental chemistry of batteries and battery storage. And so this is well publicized kind of statistic, but battery costs have been on this like very long, last decade declining cost curve, primarily from advancements in battery chemistry, but as well as just the scale volumes, right? The electric vehicles are using an enormous amount of cells, and we are able to take sort of the best in-class technology that has been developed over the last decade with lithium iron phosphate batteries and battery storage and battery management systems, a lot of which has been done for the EV market, and apply it to home storage. Anything I missed there?
No, I think it's becoming obvious to people, particularly in the investment community, that we're in the midst of a generational increase in electricity demand. A lot of that is driven by AI data centers for sure, and that's kind of the topic du jour today. A lot of that's driven by the electrification of transportation. I think people still underestimate the extent to which EVs are penetrated in the U.S. I think if you ask people what they think new car EV penetration in the U.S. is, they'll tell you 20% or 30%. The real answer is closer to 5%. Of course, in Europe, it's closer to 20%, and China is closer to 25%. Those are leading indicators, obviously. So we think that electricity demand is poised to grow significantly in the U.S., and a lot of that demand is going to be met with intermittent solar. And the reality is the cost of deploying solar and wind, but particularly solar, has come down really rapidly over the last decade, and that's going to create incredible demand for battery storage. And we think that existing instantiations of battery storage fall short, frankly, in terms of how quickly you can deploy those assets to the grid, and where you can do it, and kind of how you can pick your spots in terms of where to put those batteries and how quickly to deploy them. And so those things all kind of informed the decision to start the company.
I think it's actually a wonderful segue to my questions about product, which include, you've spoken before about the quote-unquote deployment factory and the need to go build modular, repeatable processes to go create, install, and manage a lot of hardware for homes, all over the state. Can you just share more about how that all works?
Certainly, yeah, and I think maybe it's helpful to start very briefly with why this is a challenge or why it's hard. So if you're going to go put batteries on the grid today without our model, most of the time, or basically all of the time, you do it in, think like shipping container-sized batteries. So you go buy farmland, you clear it, or you clear land, you buy already cleared land, you pour a bunch of concrete, you do a ton. It's basically a huge construction project. And you do that all at once, and you get a lot of batteries, but it takes a year to do the construction and many years to wait in the interconnection queue, basically to plug it into the grid, for lack of a better way to phrase it. So that makes sort of repeatable. You're sort of doing that once or twice in a year. A big company that's doing this, they're developing a handful, single-digit numbers of battery projects, and so you don't really need a sort of manufacturing-esque, high-volume, repeatable, sort of down to the minute and down to the second timed process like you do in our model, which is doing this at scale in the many, many thousands over time, many tens of thousands over time. And so the deployment factory is the concept that we've developed that is essentially taking best-in-class manufacturing practices, division of labor, good automation, software surrounding it, QA processes, training, right? All of the things that make a good, efficient factory that's building widgets or cars or anything run, but doing that in a distributed way on homes across Texas today. So what that looks like is we acquire a customer and we do all of the upfront permitting, and we call interconnection agreement and site survey, basically understanding if their home can accept the battery, do that all digitally and primarily automated with software that we've developed. And we have a very efficient process for assigning an electrician, doing scheduling, and then the physical install day all of the individual processes, from what tools are brought to the site, to what pictures are taken at the end, to physically how it is hooked up, to what documentation we provide and training we provide our installers. All of that is thought out, again, in this sort of like manufacturing-esque way. And so that enables us to install batteries in a matter of hours of sort of like physical site time and a matter of days from when the customer signs up. Normally, sort of from competitors, you'll see that it typically takes many months to get a battery on the grid because it's all very manual and bespoke and sort of thought of as a project. In our case, again, we can do it in a matter of days, depending on the city. Typically, our average is on the order of 2 or 3 weeks.
So as you scale and serve more customers, what are the bottlenecks in your supply chain or challenges you'll have actually scaling that?
Yeah, scale is really interesting. So a bunch of different things all have to come together on the day of install, right? So it's the hardware, this is supply chain, let's talk about that in a minute, the electricians or installers, and then the homeowner needs to at least allow us there and be, be interested in the product. On the supply chain side, as I was mentioning, there is a ton of production build out for lithium iron phosphate, which is the technology we're using today, lithium iron phosphate cell supply. So we think we're pretty well poised to take some of that excess capacity that we think is coming online over the next few years. Similarly, on the installer side, one of the things we're doing is breaking out a lot of our install tasks and trying to make them as sort of low skill required as possible and train up our labor force. We will certainly run out of very highly skilled electricians, and so we are trying to both de-skill the operation as well as build out a training program to upskill the labor force and just make this work far more accessible to many folks. I think this is like a under-discussed and underappreciated challenge with a business like ours that requires some sort of physical presence, physical labor. This is the case for many manufacturing businesses, is both de-skilling the requirement via automation and upskilling the existing labor pool to meet that requirement.
Yeah, the big kind of groups of operations challenges are hardware sourcing and supply chain management, installer scheduling, and last mile logistics. And doing all of that, as Justin mentioned, kind of in parallel to get it to happen in a matter of weeks instead of months requires the build out of a bunch of custom tools, because the way the industry works today, specifically for home battery installs, Justin did a good job of kind of comparing it to utility scale, but for home battery installs, if you go buy a home battery from one of the existing kind of upfront sale focused home battery companies, they typically will sell you the product, typically with some kind of financing, and then connect you with a third-party electrician, or you'll buy the product directly from the third-party electrician, and you'll deal, and this is a kind of owner-operator local electrician. It could be a national chain, but you'll work with those folks to do the permitting, do the interconnect agreement, schedule the install, and it's a bit of a, not exactly an elegant handoff from party to party. By managing the whole system ourselves, we can build software, as Justin alluded to make the process a whole lot more efficient, and most importantly, a better experience for the customer, but really less expensive for the customer. All of these things, these optimizations, they help us drive down the cost for our customers. And at the end of the day, that's why we're here. Back to the mission, it's about delivering affordable, reliable power for our customers, which means the most affordable home backup on the planet, which is enabled by all of these optimizations.
I would say not quite elegant is an understatement there, right? So this actually takes me to my next question, which is going to be more about the customer journey, right? What are the key steps involved from customers hearing about you to making a purchase decision to going through the entire flow with respect to the economics, which you alluded to already, and then also kind of the job to be done and the brand message that you're putting forward? Today,
I mean, our goal is to make it as seamless as possible to get home backup and access to our affordable electricity rate plans. Today, if you want home backup, your options are really twofold. One is you can buy a battery from one of the existing home battery kind of sales-focused companies. The other is that you can buy a generator. There's small portable generators. There's large kind of in-the-ground natural gas line-connected generators. Both of those options typically will run you anywhere from $10,000 to $20,000, depending on the size. Of course, the small portable generators could be $1,000, but that's not going to back up very much of your home. The power output is going to be pretty low on those. So for a comparable generator to the kind of the scale of battery that we're installing, it's going to be orders of magnitude more expensive than our offering. So with Base, you sign up, you pay a small fraction of what you pay with one of the alternative providers, and we directly with you schedule the installation in a matter of weeks with a few kind of back and forth text messages, phone calls, whatever is preferred by the customer. This doesn't take a bunch of back and forth. It's like pretty straightforward. You come into our website. I mean, I encourage folks to go online to basepowercompany.com. If you live in Texas, you should sign up. If you don't live in Texas, you can use the Texas address to kind of see the sign up flow and kind of stop when you get to the payment point. But we've made things pretty seamless and tried to put a bunch of content on the website so that people can answer their own questions and kind of get all the way to scheduling their installation without having to jump through a bunch of hoops.
It's worth noting we handle, because we're vertically integrated in this way, we handle all of the items that normally the customer would have to handle surrounding the permits and that sort of thing. And working with the electricians, again, we own all of that. So it's abstracted away from the customer, and basically we say, hey, we're going to be ready in a week to install your battery. Does this day work? And that's it.
So what is the driving impetus from the customer point of view? Is it wanting to have home backup in case of outage? Is it the cost element of being able to draw from the grid at lower rate points?
I think that early data, and of course, the product's only been available since May, and we're constantly learning and iterating and trying to get feedback from customers. But the early data suggests that most customers sign up with Base because it's the most affordable home backup on the planet. And they want protection from power outages, but they're not willing to pay $10,000, $15,000, $20,000. And so Base is a no-brainer for them because it allows them to get that peace of mind, that backup protection at an affordable price. We also bring the added benefit of an extremely competitive retail electricity price, which is great, and people love saving money on their monthly bills. But it seems that the real strong driver is affordable home backup.
Why start with residential and consumer focus rather than a more commercial enterprise flow, given that backup is probably very important to some businesses as well?
There's a bunch of reasons. I mean, you could point to the size of the market, right? It's just a massive, massive market. And the commercial opportunity with regard to the size of the market is extremely attractive. But I think it's more that it aligns with our mission, right? It's promoting human prosperity through energy abundance by lowering prices and increasing availability of power. And, if you don't protect people from outages and provide them with affordable power at home where they spend most of their time and consume most of their power, you're not really solving the problem. We do think the commercial market is important and interesting and attractive, and we plan to make our way there over time. But the residential market is really where the problem is. If you look back at Winter Storm Uri, if you look back at Beryl over the summer, at what's happening in Florida right now. Obviously, we don't serve that market yet, but you have people in their home who, in the case of Uri, are freezing to death. In the case of Beryl, are going without power. In the Texas heat, in the dead of summer, for days or weeks. And I think we all here feel very passionately feel very strongly about solving that problem for consumers.
Yeah, I think the other thing I would add is there's kind of two other points. One is with the residential or direct-to-consumer model, you can build a brand, right? And the brand is really important from a go-to-market perspective, obviously. And I think one thing that I've noticed and learned over time is that even though a brand might not be in theory as important for a commercial sale as it is for a residential or sort of direct-to-consumer scale, people are buying it in either case, right? It's a person who owns a home or a person who owns or operates a business. And so building that brand with the residential sort of part of the market is super important. The other thing, and this is maybe not exactly what you asked, but I think is an interesting point to make, is sort of where on the grid you put the battery. Do you put it at the very edge? Do you put it a little bit less, a little closer to the center or towards the power plants? And our view is that the more distributed, the more downstream, the more load side connected the battery can be. It is far more effective for obviously backing up during outages, but from the grid's perspective as well, you're able to shave load and affect demand, not just affect supply like you would if you had the battery further upstream in the grid.
So you launched in Austin in May, went to Dallas, Fort Worth in August. Can you share any metrics or details on traction so far?
Yeah, we've got a couple hundred batteries in the ground, tracking to a couple thousand batteries in the ground next year. On the order of tens of thousands of people who have expressed interest online. And we're kind of scaling up as fast as we can, as we talked about earlier. The constraint is, building the machine, right? If, there was a point where installing 1 battery a day was a really exciting milestone for us. I think yesterday we installed 9 batteries. So, getting that daily rate up to 9, 10, 11, 12, 15, 20, 30 a day is really the core focus of the team, certainly the deployment operations team. And so, we're early in our growth ramp, but off to a good start.
So your main revenue stream is, for now, the arbitrage of power cost and grid services. Although to get there, I think you'll need to build a big portfolio of batteries kind of distributed across a lot of customers on the edges you mentioned. Can you just describe how that business model works and kind of how you can leverage the battery network to go actually make money while saving customers money?
Well, there's really 3 ways we make money. So one is we charge an upfront fee for the product. Now it's a fraction of what you might pay for the equivalent size battery or generator asset, but that is one way we make money. The other is we become your power company. So every month you buy your electricity from base and we sell that power to you. And then the third way we make money is what you're alluding to, which is what we call grid services. And really the way that works is when the grid is stressed, there are times of peak demand. We discharge power from the batteries, and then when the grid is at times of low demand, we charge up the battery. So to oversimplify, we're typically charging the batteries from 10 p.m. to 4 in the morning, somewhere in that window, and we're discharging the batteries between 7 and 9 p.m., right? When the sun is going down, when everyone's at home with their TV on, their dishwasher running, and they've got friends over using a lot of power, and power prices are spiking. So what we say kind of flippantly is that we want to make your home run on 4 a.m. power, not 6 p.m. power. That's really what we're doing on the grid services side of the business.
So moving on to markets outside of Texas here. You mentioned earlier that outages and grid problems are not limited to Texas. They're all over the place due to natural disasters in Florida that we're seeing this week. There's numerous political challenges in California, right? You've mentioned earlier deregulated energy markets are a big opportunity to go use modern technology to make the grid more stable and cost efficient. There's about 15 other states with somewhat deregulated markets. So how do you think about scaling outside of Texas in the long run?
Yeah, I mean, the other deregulated states are certainly an attractive opportunity, but the rest of the country, the 2/3 of the country that are regulated, are, you could argue, equally or more attractive, kind of depending on how you look at it. The reality is we are a distributed energy technology company. Every person at the company is working on developing technology, hardware, software, deployment operations to scale the power grid, right? Solve problems on the distribution grid. We've opted to package that technology behind a business model that leverages competitive markets in the deregulated parts of the country, specifically in Texas. We certainly are looking at packaging that technology and bringing it to the regulated parts of the country behind a different business model that partners directly with the utilities, as we mentioned earlier. So, you spend time in this office, what you'll see is a bunch of people who are working on technology to make the grid better. And we think that technology is needed in the deregulated states and in the regulated states. But as a place to start, we think the deregulated states make the most sense. So we're starting here in Texas. We'll eventually go to the other deregulated states. And we may, in parallel, take the same technology to the regulated states.
It's worth noting, and maybe obvious, but Texas is a huge place. It's the 8th largest economy in the world. It's larger than most countries from an economic perspective, and so there's a lot of room to run here, just in the state of Texas, just in ERCOT.
It's also a particularly good place to build a business. And so for all you entrepreneurs out there, if you're looking to figure out where you're going to build a company, we highly recommend doing it here in the great state of Texas.
That's right.
Today, how heavily affected are you by this regulatory environment, both from a doing business perspective and from an energy perspective?
Yeah, I think it's funny, deregulation is a little bit of a misnomer. We kind of joke about it. It's not like there are no regulations. Really what deregulation means, just very simply, is that the company who owns the poles and wires and transformers and substations cannot be selling you electricity, and they also can't own generation assets or storage assets. That's really all that deregulation means in the context of this discussion, at least. Energy, and even energy in Texas, is a heavily regulated industry. And so there's a ton of things on the consumer side as it relates to our retail electric provider model. There's obviously a ton of items as it relates to code compliance and installations on homes. That's from a safety and certification perspective. And then there's a ton of regulations as it relates to how we interface with the utilities, right? Even though we are in a deregulated market and we sell power to customers through our rep, we still interface with the utilities because we're putting power back on their system, right? And so they have a bunch of rules and regulations and codes and requirements and safety things that we work through. And so I would say regulatory affairs and policy work is actually a big part of our business, something we're spending quite a bit of time on. And, it's interesting, from an outsider's perspective, it might seem that Texas and renewable energy, just from a political standpoint, might be a little bit at odds. It turns out it's really not. Batteries, especially batteries on the distribution grid in a distributed fashion, are a really techno-economic optimum product to add robustness to the grid and increase reliability. So we've seen actually a lot of really positive support from folks in sort of all aspects of the regulatory environment.
Yeah, we've been really encouraged by the collaboration between regulators and policymakers and technology companies like Base in Texas specifically around upgrading the power grid with new technology. And so, to Justin's point, it's a highly regulated industry. Deregulation in this context really just means retail competition. And that's part of why we decided to start in Texas, because we could go to market immediately. We didn't have to wait to strike a deal with a big investor-owned utility. But in a deregulated market, we still work very closely with the policymakers, the regulators, to make the kind of conditions by which technology companies operate more conducive to the opportunities that are out there to make the grid more reliable and scale capacity.
So what are the other policy issues or initiatives that you're focused on in the coming years to go make Base most effective here in Texas, but also most effective expanding to other states?
I mean, we could bore you for hours with details on permitting reform and but I mean, there's a lot of kind of specific details around things like permitting reform and electrical codes, and I think the kind of zoomed out way to think about it is that the existing system is kind of outdated by definition. And as the technology changes and gets better, we need new rules and requirements to adapt to that new technology. And, you've seen this in basically every industry ever, especially one that is working on safety critical systems, right? So dealing with the power grid, dealing with people's power at their home, you're going to have regulation. And like I said, we've been extremely encouraged by the willingness of the regulators and the policymakers to collaborate with us as the leaders kind of on the technology side to figure out what is coming and how can we adapt the rules and the regulations around that technology.
Yeah, and my sense is that this is a pretty unique thing to Texas, right? Texas kind of does its own thing in certain ways, and that's certainly the case with the grid, right? It's its own islanded grid, and so a lot of energy innovation in general happens here in Texas, we've noticed, and that's because of the sort of regulatory environment and the sort of forward-thinking nature of the Texas Legislature, Public Utilities Commission, and sort of folks surrounding both of those.
Yeah, Texas should be the energy capital of the world. As we mentioned earlier, it's in the middle of the Sun Belt, it's in the middle of the wind corridor. We got a ton of land, we got ports, we have competitive free markets, we have great engineers, operators, technologists, lots of capital, and a local government and a state government that's willing to work with technologists to usher in the future. So we're extremely bullish on Texas as a place to build a company, but specifically as a place to build an energy business.
You mentioned the decentralized nature of your general approach. What are the advantages of that compared to a more centralized battery operation?
Yeah, I think this is a really interesting and maybe nuanced or technology-driven point, but I think it's really important for folks to understand, especially those interested in the grid and how the grid works and the engineering behind it. So think about the grid as sort of as a network. You can have storage on the network all concentrated in kind of big areas, or you can have storage distributed at the edge of the network, sort of at the branches of the tree as opposed to the trunk of the tree. And our view, and there's a lot of both like third-party research to back this up, is that having storage at the edge of the grid is really effective in order to make the grid itself more efficient. So if you look at any given line on the grid, there's a metric called load factor. This is maybe a little bit nuanced, but basically it's like how much of the time is that line used to its maximum capacity. And what you might be surprised to find is that that load factor is actually typically very low. Most of the time, that line is very underutilized. The problem is that it's overutilized certain parts of the year, certain days of the year, certain hours of those days, and that drives, or that tends to drive a lot of outages and a lot of requirement for upgrading of infrastructure. But if you're able to put storage co-located with the load during times of high demand, you're effectively able to turn off that home or that business from the grid. And so now the battery is supporting that load as opposed to the grid supporting that load, but you can only do that with the battery connected to that load. And so distributed batteries are a really effective and interesting technological way to improve the efficiency and reliability of the grid. The other thing that's really nice is that because you have batteries distributed in a bunch of different places, you can pinpoint certain areas of the grid that need support, and you can go either deploy more batteries or just discharge those batteries that you have in that area down to the individual home level or the individual substation level. And this is not something that a centralized typical grid scale battery can do. And it's just enabled by that distributed energy technology that we're developing and the software that connects all the batteries to say, that one needs help right there for the next 15 minutes, so we'll discharge right there. That's something that totally is unique to some of the technology we're building.
Yeah, you also benefit from data that you're able to collect by having grid assets spread out on different nodes and different load zones. When you put a battery kind of next to a substation on the grid, you collect a certain amount of data on what's happening at that load zone, at that node. But by having batteries all over the grid, specifically on residential homes, you're able to build a really valuable data set on what's happening on the grid in different specific areas at different times. If you look at power prices in ERCOT in Texas, demand is actually generally driven by residential HVAC, right? You have really hot summers. You have sometimes uncharacteristically cold winters. And so when people are cranking their AC kind of in either direction, that's what drives a lot of the demand squeezes and price changes. Now, of course, there are other reasons why prices move on the grid, and we're certainly building expertise in that, but are not experts in energy trading today. We have some folks on the team who are, but we're not a commodities trading firm. We're a technology company. But as a technology company who deploys these assets on the edge, we're able to build up a really unique data set that really no one else has by putting computers effectively on the circuits at individual homes.
Last thing I want to touch on is the base team. You and I have talked a little bit off camera about this. Some people in the Contra network base. What kind of team do you want to build? How's it been going? And who do you want?
First, I'll just say that the team is the company's most valuable asset. Previously we talked about this distributed batteries and generation and that really being the core asset. But at the end of the day, the team is the company's most valuable asset, right? A company is just a bunch of people in a room clicking on keys, and if you don't have the best people in the world clicking on those keys, you're in for a tough go, particularly if you're in a competitive industry like energy. So we've been laser focused on recruiting the best people in the world to join the company. I think that when you take on a really ambitious vision and mission and strategy like we are at Base, where we think we have the opportunity to build a really massive company and actually promote human prosperity through energy abundance and affect people's lives and put it in the universe, it makes it a heck of a lot easier to attract top talent, because the best people in the world, they want to work on hard problems, they want to be in an intense environment, they want to be pushed to do the best work of their career, they want to work with hardworking, smart people who take their work really seriously. And so if you spend time with the Base team, you'll find that people are intense, they're direct, they're smart, they work hard, they're very mission oriented, they're very focused. And so, that is the kind of people that our culture attracts. And we've been very lucky to be able to build a team of really talented folks. And I think, a lot of credit to Justin and our early team. We have many folks. Justin started his career at SpaceX and spent time at Anduril. We have a bunch of folks who've come from SpaceX and Anduril and other companies like Tesla and Apple, and folks I met through my time as an investor, and folks like you guys at Contrary who have helped bring exceptional talent into our orbit. So we'll never really kind of lose sight of that, and recruiting the best talent in the world will be a core focus of us and of the company as long as we're around. So to any great engineers or operators out there who want to be a part of something special, put it in the universe, do the best work of their career, please reach out.
Last quick question. We ask this when investing actually sometimes as well to set kind of a high level framing of the challenges and opportunities ahead. if the company, in theory, were to fail in a few years, why would that be? And conversely, if it were to work, what would be the one thing that you really nail that takes you guys off?
The risk or the failure mode is kind of execution risk. There's a lot of really hard things that are happening in this building, right? There's hardware engineering, there's software engineering, there's deployment operations, there's supply chain, there's capital and financing, there's regulatory work. And as we've talked about at length, we have to make all those things happen kind of well and at once, and that's very difficult. So I think the failure mode probably looks like some level of execution misstep, and I think you could say the same thing about the success case, right? It looks like kind of nailing execution across a bunch of different vectors, solving really hard engineering problems across multiple domains, kind of at the same time, and then having really world-class execution to bring those engineering solutions into the world. Financing those things effectively, doing effective policy work. So it's really kind of building this complex coordination machine effectively. I think, candidly, that could be the downfall of the business, although we certainly don't plan for that to happen. And that also will be the reason why we succeed.
Wonderful. That's all I have. Thank you guys so much for sitting down.
Thank you.
Thanks.
Great chatting.